have this slide listed on your content page. What this slide describes are different special factoring patterns that we're going to be kind of looking at. We're going to have the difference of squares, and then we're going to have the square binomial sum, square binomial differences. Those are actually kind of the same thing. I know I have listed as case 2 and case 3, but those are kind of the same thing. And then the sum of keys and the differences is almost the same thing as well. But we'll look at all different ones of these. So the first one says completely factor a polynomial if possible. So we're going to look at this. We got 25 minus 16x squared. So the very first thing we're going to ask ourselves in problems that look like this is this a perfect square? Okay. If you answer that, you say, oh yeah, this is a perfect square, and this is a perfect square. I'm going to give you a little thing really to know that is a perfect square. Here's a list of perfect squares. The sheet shows a list of your squares and then square roots, both the first column and the second column. I'll show you that you can see that you got the 1, the 4, the 9, 16, and the 25. Those are considered numbers that are perfect squares because a number, that same number times the same number made that number. Because to make 25, you had to have 5 times 5, or 5 to the second power that made that. Okay, so that's what you're looking for. All these different numbers, you're welcome to take a screenshot of that because this will help you out, especially in that third column. That's going to come up when we do the sum of cubes and the difference of cubes. Back to it. We got 25 minus 16x squared. Okay, so we've determined that this is a perfect square. This is a perfect square. This is also a perfect square because x times x makes this. So, that being said, we know that we typically have two parentheses that makes a trinomial. In this case, we're going to have kind of the same thing. But we go, well, to make 25, we need a 5 and a 5. And to make a 16, we have a 4. A 4. And to make the x, we have an x and an x. Now, we have to think about this. To make a negative 16, we need a positive times a negative to give us a negative product. So this has to be plus and negative. And now you might tell me, hey, Mr. Moore, normally we have a middle term in here. We have this constant, which is normally in the back. We have this thing, which is normally in the front. So let's look at how we got here. If we do 5 times 5, we get 25. And if we do 5 times negative 4, we get negative 20x. And if we do 4x times 5x, we get 20x. And if we do 4x times negative 4x, we get a negative 16x squared. And that doesn't exactly look like that one just yet, but if you think about it, we're going to have to simplify these middle terms. Now, these are the exact opposites, which makes each one go away. So, in fact, we do end up with 25 minus 16x squared. And this scenario happens with all these difference of squares. So, the qualifications for this is you have to have a perfect square here, a perfect square here, and it has to be separated by subtraction. That's what we call a difference. Okay? If this is addition, this does not qualify as it because we need it to a positive and a negative to cancel out this middle term. So we need the version of both those to make it the middle term go away. So this is our final answer. This 5x plus 4x and 5 minus 4x. Okay, next is completely factored polynomial. We have 25x squared minus 4y squared. Now, once again, we look at our list, and we'll notice that we have 25 is a perfect square, and 4 is a perfect square also these x squared and y squares are perfect squares. So we know we're going to need 5 times 5 to make that 25. We know that we need 2 times 2 to make that 4. We need x times x. We also need y times y. Now, just like we had on the other one, to cancel out the middle term, we're going to need a plus and a minus. That also makes this be a negative. Move back to the polynomial if possible. We have 25x squared plus 30x plus 9. This one can be represented by our square root of binomial sums. Now, what it's saying is that this is kind of the method that this thing should be set up. So this is what this is represented by. We got plus 2ab, and this part's going to be represented by b squared. Okay. So basically what this means is this thing is times by something. And what's going to happen with this is going to turn into just the square root of that term. And then it's going to be, we're going to steal the sign off this one. And then it should just be this one squared if this thing works. Okay? So in order to get from here to here, all we did was just take the square root of this thing. Okay? So the square root of 25x squared is 5x. And now to get from this term to this term, we just take the square root of that one. So the square root of 9 is 3. Okay? And so our middle term is plus, and so we just steal a plus from that. Okay? And so this thing might just be squared. Now, this thing checks out. We know that 5x times 5x makes this 25x squared. So this thing works here. And we know that 3 times 3 makes this 9. So this thing checks out here. The only thing that we're kind of clueless about is whether or not this works. Is this middle term correct? So the way you do it is exactly what you're doing here. Remember, this is represented by your A. This 3 is your B. So what we're going to do is do what it says here. We're going to multiply A times B, and then we're going to multiply it times 2. So if we do 5x times 3, that gives us 15x. Now if we do 15x times 2, 15 times 2 is 30, and we got the x still with it. So this thing checks out as well. So this is our answer. I know this made it a little bit confusing to put these things underneath it. Next time I do it, I won't do that. I might just write this one, just so you know you got times about 2. But this is our answer. All right, completely factor the polynomial if possible. We have 9y squared plus 24x squared y plus 16x to the 4th. Okay? So we're going to do like we did on this one. We're going to be looking for the square root of this term. So it might just turn out to be like this. Anytime we have a trinomial on this, we're going to kind of do it the same way we did on the last one. So the square root of 9y squared, well, 3 times 3 gives me that 9. And y times y gives me y squared, so this is 3y. My middle term is positive, so I'm going to make sure that I have a plus in between here. And then I know 4 times 4 gives me 16. And this one's a little bit different. This is x to the 4th. So I know that y times y gives me y squared. But on this one, we're going to look at it like it's x squared, because x squared times x squared gives me x to the 4th. It's a little bit unusual. So this might be our answer. So we know it works because we did this one. We know it works because we did this one. And remember, we're doing 2 on this one. This is what this is supposed to look like. Remember, this is our A, and this is our B. So we're going to multiply these times each other. So 3y times 4x squared is 12x squared y. And if we times it by 2, 12 times 2 is 24, and then we got our x squared y. So this thing checks out as well. So this is our answer. Completely factor the polynomial if possible. So just like we were doing on the previous sections, our very first step needs to be that we try to take out a greatest common factor. Now, if we look at both these numbers, we'll be able to decide, hey, we can take out 3. We can divide out 3 out of both these. So what that does is leave x squared minus 9 behind. Now, if you look at both these, you're going to go, hey, these are the perfect squares again. Okay, and this is difference of squares. Remember, if we had just 2 terms here and subtraction between them, and both these are perfect squares, this should turn into x plus 3. That's the square root of that one, that's the square root of that one, and we also get the negative version, so then we get x minus 3. Completely factor the polynomial if possible. Alright, so now we got one of these trinomials again, which says that this is going to be the. So what we're going to do is we're going to be looking and saying, hey, what's the square root of this one? Let's see, well, it's 2x. So what's the square root of this one? Let's see, well, it's 3. So what was the sign on this one? Let's say it's plus. So this could be correct. So we check this, we check this. Now we just have to check this middle term. Remember, we multiply this times this, and then times it by 2. Well, 2x times 3 is 6x, and 6x times 2 is 12x, right? So this does not work. This one didn't turn out to give us our middle term. When these don't work, you'll find that's the case, is this middle term is going to be off. So this is not special factorization. Completely factor the polynomial if possible. We got 16x squared plus 32xy plus 25y squared. So once again, we got a trinomial. What's the perfect square of this one? We get 4x. That's the perfect square of our last term. We get 5y. And then our middle term is positive. So it might be this. Let's just double check it. And we check this one, we check this one. So if we do 4x times 5y, we get 20xy times 2 is 40xy. This does not work once again. Completely factor the polynomial if possible. We have 8xy squared plus 8xy plus 2x. For the very first step, we want to take out a greatest common factor, and 2x. So we can divide everything by 2. We can take out an x out of everything. Let's see what we have left. 2x, 8xy squared divided by 2x is 4y squared. And then we get plus 4y. And then 2x divided by 2x is 1. Now once again, we got perfect squares on both these, right? So this thing will have this 2x out in front. But this could just be the square root of 4y is 4y squared is 2y. Middle term is positive. No, the square root of 1 is 1. So it might just be this, but let's double check. And this worked. This worked. We have to double check this middle term. 2y times 1 is 2y times 2 is 4y. So this thing works. This is right. All right, completely factor the expression, if possible, 8 plus 27y cubed. So this one, I think, looks a little bit different than the ones we've been doing, and that's because these are perfect cubes now. Okay. Now when we're doing cubes, it follows this pattern. So we have something that's being cubed here. We have a different thing that's being cubed here. Now, what's going to happen is that we factor this apart. These things are going to equal. This is going to be the cube root plus the cube root of the other term. And then we're not even going to use what we referenced back here. We're going to reference this. So what this is going to be is a squared. And then this is going to be minus a times b. And then we're going to just finish with b squared. Okay? So let's go down our list and just do this. So you just have to know these patterns, and once you kind of figure out what you have to do, these things will just kind of fall in place. So the cube root of 8. So what we're thinking is what times what equals 8? So you can look on your sheet and you can figure that out, but the answer is 2. 2 times 2 times 2 equals 8. Just like with this one, it's going to be 3 times 3 times 3 equals 27. So this answer is 3. And now y times y equals y cubed. So that's what goes here. So from here, we just got to follow our pattern. So this is a squared, so we're going to reference this term, which is the 2. 2 squared is 4. So that's what goes here. We do go ahead and solve that out. Now we have minus. And we're going to do a times b, which is, and we kind of ignore the sign. So even though we have minus here, this turns out to be positive. Just ignore that. We know it's supposed to be minus. 2 times 3y is 6y. And then we're going to finish with our last one squared, our b, which is this 3y. So 3y times 3y is 9y squared. And this is going to be our answer. Now, you're more than welcome to go through and see what happens here. And this is kind of neat to do it. We'll do it right now. So what we're going to do is we're going to multiply this first term times all 3 of these, and our next term times all 3. And then we're going to combine them and see if we end back up with this 8 plus 27y cubed. So let's do this. 2 times 4 is 8. And then 2 times negative 6y is negative 12y. We do 2 times 9y squared, that's going to be 18y squared. Then we do 3y times 4, that's going to be a plus 12y. And if we do 3y times negative 6y, that gives us negative 18y squared. And if we do 3y times 9y squared, that gives us a positive 27y cubed. Now you'll notice that this term and this term are exact opposites, so they cancel each other away. Just like the 18y squared and the negative 18y squared. So all that's left is 8 plus 27y cubed, which is what we started with. So this thing checks out. So this is this factor out. expression if possible. We got 64 plus 27y to the 6th. All right, we're going to follow that same pattern here. So we're going to be looking for the cube root of this 64. So cube root of 64, you'll find is 4. 4 times 4 times 4 equals 64. And then we have plus, and then we got 27, which we had up here. We know that's going to be 3. 3 times 3 times 3 is 27. And this is kind of unique. We got y to the 6. Now, you can make this happen pretty easy. We know that if we take 3 and we divide it by 3, we get that 1, which is where that comes from. So we're dividing these by 3. So 6 divided by 3 is 2. So we get y straight here. So we can get there that way. We know that 3y squared times 3y squared times 3y squared gives us that 27y to the 6th. Okay. Now we're doing this. We're squaring our first term. So 4 times 4 is 16. Now we go to minus. And then we do these two together. So 4 times 3 is 12. We have the y squared with it. And then we just square our last term. So 3y squared times 3y squared is 9y to the 4th. And you're more than welcome to double check it. One thing I want you to notice about the pattern, remember we have our, this is a cube root. And this is a cube root. And then we square the first term. So remember this is a squared. And then this is multiply them together. This is kind of how I remember it. And then the last term squared. Okay, so we kind of know our pattern as far as what math we're doing. Now, one thing I want you to notice about these signs is this. These signs, whatever this starts with, this thing is always going to be the same sign. So we started with addition. We're going to keep it the same. Then it always goes to being the opposite. And then it always ends with addition. So just remember that little pattern. Same, opposite, add. This will let you know what type of signage you need to have, what operations you're doing in between here. And it works the same way when you're doing difference of squares, because those start is a cubed minus b cubed. And so if you're trying to solve those, well, you take the cube root, which is a. We're going to keep our sign the same, which is minus. The cube root of this is b. Remember, with our next thing, we're going to take the square of this one, which is a squared. Now we're changing the opposite. Remember, we started with minus. Now we're going to the opposite, which is addition. Then we put them together. So a times b. And then we finish with addition. So plus, and then we finish with our last term squared. So we got b squared here. Complete the factored expression if possible. So the last one we do, we have ax cubed minus y cubed. What we're going to do here is we have 8, and so 8 is made up. The cube root, we've already done that. And it'd be 2. We know x times x times x gives us 2x cubed. Keep our sign the same, so this is minus. And then we got cube root of y cubed is 1. We're going to square our first term, so 2x times 2x is 4x squared. We're going to change the sign, so same opposite now, so plus, multiply these together, so 2x times y is 2xy in the condition, and then we do y times y, which is y squared. Let's see.